Okay, so these are the Unit 4 notes for Algebra. We're going to start with Lesson 1. We're going to be focusing on taking exponent properties and specifically zero and negative exponents, and we're also going to be talking a little bit about scientific notation as a review. So once you're done with the notes, go ahead and attempt the workbook problems as shown in the unit plan, and then we'll be able to move through this together. So let's get started. Okay guys, so the first thing I want to talk about is the fact that you can find all of these videos on the YouTube channel for Disney Nerd Dad, and I'm also going to make sure you guys understand that you have the exponent properties, flipped classroom unit plan. We are on day 1, scientific notation and zero negative exponents, so you'll be completing the notes for Unit 4 Lesson 1, and you'll be completing odds or evens on 2 separate worksheets, but we'll go over an example for each of those so that you guys get started. And of course, if you guys are having trouble and you need extra assistance and I'm not immediately available on the Xboxes, there is also a couple videos about scientific notation and exponent expressions and equations, specifically talking about zero and negative exponents. But anyway, let's get started. So in Unit 4 Lesson 1, we're going to be talking about using properties of zero and negative exponents to simplify expressions. We're also going to apply these properties when using scientific notation, and we're just going to review some scientific notation stuff that you did in 8th grade to make sure that you guys are on board with what you need to do when you have scientific notation questions. First thing I want to talk about in Unit 4 is the monomial and polynomial chapter. And a monomial is a number, a variable, or a product of a number and one or more variables. And expressions that involve division, addition, or subtraction of variables is not a monomial. Okay? So again, a number, a variable, or a product of a number and one or more variables. If there's division, addition, or subtraction, that's not a monomial, that's a polynomial. One of the things we have to keep up with is we need to make sure we can simplify monomials. Monomials are simplified when each pace appears exactly once. There are no parentheses left. And there are no zero or negative exponents left. All right. So in your calculator, I want you guys to do 2 to the 4th power. When you do 2 to the 4th power, you do 2 and then you do the caret 4 and you realize that it's 16. If you do 2 to the negative 4th power, you get a fraction, and when you do math enter, you find out that that's 1 over 16. 2 to the 3rd is 8. 2 to the negative 3rd is 1 over 8. 2 squared is 4. 2 to the negative squared is 1 over 4. 2 to the 1st is 2. And 2 to the negative 1st is 1/2. Now, I did this way on purpose. It's because I want you to understand where the mistake comes in. And the mistake comes in is that people who say anything to the 0 power, they automatically say 0 because you've been taught that 2 times 0 is 0. But the problem is, think about it. Is there any number in here that's negative? No, there's not. And so as I work towards the middle, what's in between 2 and 1/2? Well, there's lots of numbers between 2 and 1/2, but the number that should come into your mind the most exactly is 1. And so the rule, and as we're going to fill out down here, is that anything to the 0 power is equal to 1. And you can try all these in your calculator, and every time you do them, and I want you to try them, you should get 1. So go ahead and check these in the calculator. Go ahead and pause the video, check those in your calculator, and make sure that they all equal 1, just so that we're on board with what we're trying to do. And again, now that you've unpaused it, the rule is any number to the 0 power is equal to 1. So for example, 8 to the 0 power is equal to 1. There's a couple things that we want to talk about when you have a 0 power outside of parentheses and when you have a 0 power inside of parentheses. So when I have 562 to the 0 power, that's equal to 1. When I have negative 15 inside the parentheses to the 0 power, that's equal to 1. When I have 1 divided by x to the 0, that's equal to 1 divided by 1. It's also going to be equal to 1. 4y to the 0 power divided by 7, it's a little bit interesting. Everything inside parentheses to the 0 power, that's equal to 1. But we have this divided by 7. So our final answer is 1 over 7. Okay? Only the numbers and their variables that are directly connected to the 0 exponent equal 1. So there is a difference. Negative 7 to the 0 power is equal to 1. However, negative 7 to the 0 power is equal to negative 1. 5 times 7 times 9 to the 0 power is equal to 5. And why did that happen? 7 times 9 is 63. 63 to the 0 power is 1. What's 5 times 1? 5. Okay? So go ahead and do these 5 problems. And then go ahead and raise your hand and get them checked off with me to make sure that you're applying this correctly. And then we'll move on to negative exponents. Okay, so now you've checked your notes for 0 exponents, and we're going to work on those in the classwork. But we also want to talk about negative numbers. So for any non-zero number, a to the negative n is equal to 1 over a to the n, and 1 over a to the negative n is the same as a to the n over 1, which is equal to a to the n. So, for any negative number, we have to take it to the other side of a fraction bar to make it positive. So, for example, if I have 7 to the negative squared, that is equal to 1 over 7 squared, which is equal to 1 over 49. So, if I have 6 to the negative cubed, that's equal to 1 over 6 cubed, which is equal to 1 over 216. If I have 1 over x to the 9th, that's equal to x to the 9th over 1, which is equal to x to the 9th. 1 over j to the negative 5th is equal to j to the 5th. G to the negative 12th is equal to 1 over g to the 12th. So in other words, if a number or a variable has a negative exponent, you have to move it. You move the number of the variable up or down. Once you move it to the other side, the exponent becomes positive. Like 0 exponents, you can only move what is directly connected to the exponent. And only the exponent changes to positive after moved. So, for example, with negative x to the negative 7th, this is a negative 1 here. So I'm going to rewrite this as negative 1 over x to the 7th. Notice the negative 1 didn't change, and the negative 1 stayed in the top. The x to the 7th merely moved to the bottom. In this one, we have negative 7 to the negative squared power over m to the 4th. So when I rewrite this, I'm going to handle it in pieces. Negative 7 is taken to the negative 2 power. So now I have negative 7 squared. M to the 4th stays on the top. But I'm not done. I can go ahead and square this. M to the 4th over 49. Final answer. So go ahead and pause and finish the next slide. When you're done with the next slide, check it off with me. I want to make sure you're moving the negatives where they need to be, and then we will continue with the notes. Sometimes you're going to be asked to do both at the same time. So to simplify 0 and negative exponents, the first thing you want to do is look for 0 exponents. Anything that's connected to that will equal 1. Then you're going to look for negative exponents. you've got to move anything that's negative, okay? So you move to the other side of the fraction. After you move things with negative exponents, only the exponents become positive. So when you're done, there should be no zero exponents and no negative exponents. So again, let's look at a couple of these, and I'm going to walk you through them. In this expression, we want to look at everything as one at a time, every part of the monomial one at a time. Or this is a polynomial, but we want to look at every part of this one at a time. 5 is to the first power. I'm going to leave the 5 on top. Y to the 0 equals 1, so this goes away. X to the first power is positive, so it stays on the bottom. T to the negative fifth is negative, so it has to go to the top and become positive. So I have a positive 5 t to the fifth divided by x. That's my final answer. We continue with number 2. A positive stays on the top. B to the negative first goes to the bottom, becomes positive. Negative 3 to the first power. Well, even though that's negative 3, its power is still 1, so it stays on the bottom. X to the 0 eliminates, and then y to the negative fifth changes to the top and becomes positive. So let's rewrite this. A y to the fifth divided by negative 3b. Same thing. This is a negative 1. It can stay on the top. Y to the negative sixth. Well, that needs to go to the bottom and become positive. H to the 0 gets eliminated. B stays where it's at. And finally, number 4. Why did I write a fraction bar? Well, because even if nothing ends up going to the bottom, it's still going to be over 1, and then I can reduce it and come back to it later. But we know something's going to the bottom. Negative 9 is to the first power. It stays on the top. X to the negative squared goes to the bottom. K to the negative 12th goes to the bottom. And it's simplified. Okay. So got a couple things for you to work on. The first of which is this packet, or this page on 0 and negative exponents. And again, you were told to do odds or evens. There is certainly a problem for every type of problem that you're going to be faced here. So if you just rewind the video, you'll be able to find me going over a problem similar. So I don't feel like I have to go over any of these. But what I definitely do want to talk about is the scientific notation. When we have scientific notation, we can either multiply or divide scientific notation. But one of the things I want to talk about is the fact that when we multiply scientific notation, as you've been taught in the past, you do the numbers, so 1.08 times 9.3, and so I'm going to do that in my calculator. And I get 10.044. And then when we multiply, and there's in the past you've been told you just add whatever numbers you have here, times 10 to the negative sixth. Now, the problem is this first number has to be between 1 and 10. So I'm going to have to rewrite this problem as 1.0044 times 10. Now, since I made this number smaller, this number has to get bigger. Well, what's bigger than negative 6? Negative 5. So 1.0044 times 10 to the negative fifth. That's my final answer. We're going to learn the rest of this chapter why that happens. Like I said, you guys have already been taught scientific notation, but as a review, again, you're going to be doing either odds or evens. So to be fair to the ones who did the evens, I'm going to go ahead and do this one. 16.2 times 10 to the negative fifth. That number is bigger than 10, so I've got to move it. 1.62 times 10, and again, since it got smaller, this number has to get bigger to the negative fourth. Okay, that takes care of the multiplication. Let's look at division. Number 19. 3 times 10 to the negative 2 divided by 8 times 10 to the negative 1. So we do 3 divided by 8. And we get 0.375. And then you've been told in the past that whenever you have division, you just subtract the numbers. Well, cool. Negative 2 minus negative 1 is negative 1. Now, what's the problem here? This number has to be greater than 1. So we've got to move it this way. So 3.75 times 10 to the negative second. And again, because I made the number bigger, this number has to get smaller. Same thing over here, 4.1 divided by 1.28, 3.20, 4 minus negative 5 is 10 to the 9th. That's my final answer there. Again, just a quick review. If you notice on question number 28, 0 powers come up. You also have some negatives here to talk about why they, all 5 of these moved to the top, didn't they? It's because of when we subtract. So we're going to delve into why this all happens as we continue this chapter. So please, like I say, do the notes. Now we'll add to this. You do not have to do 13 through 18. So one correction to this is you only have to do 1 through 12 and then 19 through 28, odd or even. So odds or evens. When you're done with all of this work, check it off with me. We'll talk about it. Hopefully we'll clean up any areas you need help in, and then we'll get ready to move on to lesson 2.